Yeah, certainly we have continued looking at the assignment that we have for business math and statistics. We have solved quite a good number of questions. And as for today, I just want us to focus on question number 14. Yeah, question number 14 is the one that I want us to have our eyes fixed on. And here we are. Part number A of the question is very straightforward as well. Similarly, part C of the question, if you did the work that I said, I communicated previously that people needed to go through partial fractions so that when we come here, we are not coming here to start explaining again what partial fractions are, because I'd already communicated them to you. There are those sessions I've had in partial fractions. So here we're just going straight into the application thereof. Let's get started. Part A of the question is reading. Before I read, confirm you can see the screen and can hear me clearly. Can you see the screen? Okay. Okay. A dealer finds that the sales of a certain item are closely linked to the price. He asks per unit. So if he asks for X dollars per unit, right, X dollars per unit, then he can expect to sell such a quantity of items. So in short, the quantity of items to be sold would be 60,000 minus 50x. And then the price itself, price is X dollars per unit. You get what I mean, eh? This is price. The question is saying, if he asks X dollars per unit, that's the price. The price is equal to X. And then he can expect to sell 600 minus 50X items. So that is the quantity for us. Each item costs him $50. So the cost of the items, is $50. $5. Each item. This is interesting. So this is the cost per unit, yeah? This is just a cost per unit. Each item costs $5. How much must he ask per unit, per item or per unit to maximize the total profit? So in other words, we need to find the total profit function and then maximize the total profit function. You get it, right? So now the question is, how do we maximize the total profit function when we have it? To maximize the total profit function when we find it, it is basically maximized by, differentiating it. You just differentiate it and then set the derivative equal to 0, differentiate it, and set the derivative equal to 0. Then solve for X in our case. So those are the steps that we're going to take. I repeat, we're going to find the total profit function. Then after finding the total profit function, we're going to differentiate the total profit function with respect to X. And after differentiating the function, we'll set the derivative equal to 0. When we set the derivative equal to 0, we'll solve for the value of X from that derivative. So let's go ahead. How do we find the profit? Now listen carefully. How do we find the profit? The profit is always found. This is how we find the profit function. Is total revenue minus total costs. You get what I mean, eh? Total revenue minus total cost. The question is, how do you find total revenue? Total revenue is price times what? Times quantity, right? Are you able to follow? Total revenue is price times quantity minus total cost. And our total cost in our case, since we are given the cost per unit, it shall be the cost per unit, which is in our case the $5 multiplied by the units. Okay, this will be the cost C per unit multiplied by the units that are there. That's when you can establish the total costs that is involved in our case. Okay, so the question is, I guess you're following, establishing the total profit function. What is the price? The price is X, yeah? The price is X, isn't it? We established that the price is X, so it is X times the quantity. Our quantity is 600 minus 50X. Is that clear? Are we good up to here? That's the total revenue minus total cost. Our total cost per unit is 5 multiplied by the number of units. Okay, 5 multiplied by the number of units. So it is 5 times the number of units is 600 that we're producing. We are producing 600 minus 50x. So that is that. So this is total revenue minus the total costs. Is that clear? It will give us the profit. Are we good up to here? Obviously, you're picking the idea from here. You can expand X times 600. That would be 600X, yeah? Minus 50X squared. Okay, this will give us, this will definitely give us the total revenue function minus, let's find the total cost function. What is 5 times 600? What is 5 times 600? 0, 0, 30. It should be 3,000, yeah?
Yes, 3,000.
3,000 plus 5 times 50. 5 times 50 should be 250, yeah? X, is it?
Yes, 250.
Yeah. And then you can expand from here. You will have 600x minus 50x squared minus 3,000 minus 250x. Okay, so what are we going to do from here? What we're doing from here now is basically to simplify the function, the total profit function. We need the total profit function. That's what we are looking for. Let's simplify, collect like terms together. You shall have negative 50x squared. Then 600x minus 250x is what? What is 600 minus 250?
600 minus 250. It's 350. Yes.
Yeah, 350x, right? Minus 3,000. Have you followed up to here? This is just basic simplification. We're looking for the total profit function so that we can differentiate the total profit function. Now, if you have this total profit function from here, you could easily, differentiate the total profit function the way how it is. This is our total profit function, yeah?
Yes.
You're following it, huh? This is our total profit function. Then the total profit function could be differentiated so that we can solve for x. Let's differentiate it. We are going to have drop the 2 here, the power, and multiply by the coefficient. You will have negative 100 x, yeah? Plus 3/5. Is it?
Yes.
Are we all following? Yeah. And then this will be 0 because it's a constant. Set this equal to 0. The derivative equal to 0. And then when we get here, we are solving for the value of x so that we can have 100x equal to 350. Divide through by what? By 100, right? By 100. So that x can equal to how much? How much he asks per unit? Must he ask per unit? In short, we are looking for the price that will help us maximize the profit. So we can just maybe 0, 10 into that is 3 point what? How much should it be the price? 3.5.
Yes.
$3.5. You get it, eh? This is the price.
Good.
Okay. This is the price per unit. Now that we have gotten the price per unit, that's okay. Then we can go now to part B of the question, which is not very, challenging. It is saying that distinguish between the following terms commonly used in business math: cash discount and trade discount. How different are they? We're on question number 14B. What is the difference? Cash discount and trade discount. What do you understand by cash discount? Hello?
Yeah. No idea, sir, on this end.
No idea. Okay. Now it is interesting now. Let me start from the trade discount, part 1. I want to start from the trade one. So the trade discount is subtracted from the list price of the good allowed by the trader to the customer at the agreed rate, while the cash discount is allowed to the customer when he or she makes payments for the goods purchased. Did you get it? This one is deducted from the list price. Okay. From the list price. Okay. So it is actually allowed to by the trader. The trader is allowing this discount, okay, to the customer. You get the point, eh? It's deducted from the list price. So the trader allows this to the customer. That's trade discount before payments. You get it, right? That's a key word. Before payment. I'll explain that. Then cash discount. This one, it is allowed to the customer when he or she is making payments for the goods. So this one is when making payments, right? When making payments for the good. I'll give you a scenario. Look at this, right? For example, you go to the shop, you're going to buy some goods on credit, right? You want to buy a computer whose price is 10,000. You're following, right? That's a list price. That's a calling price. And then when you get there, you're saying that you want to get this on credit. So they tell you that you negotiate. No, I don't have 10,000. Maybe I just have 9,000. You get the point, right? Then they agree to give you at 9,000. You seal the deal there. You get what I mean? That not really that you have cash. Okay? That is a trade discount. They allow you that whenever you will be paying, you can pay at 9,000. You're following, right? Now, since you're owing them, okay? Since you're owing them, they give you conditions. Let's say you are supposed to pay within maybe 1 month, right? within 30 days. But if you can pay within the first, say, 10 days, you're supposed to pay within 30 days, right? But if you can manage to make it within the first 10 days, then we can give you 5% cash discount. You get what I mean, eh? So when you go there now to make payments, you manage to pay within 10 days, you've managed to raise that money, you go to pay. Then you say, no, since you've paid early now, we can again cut from cash. Instead of paying 9,000, I think you can just pay maybe 9,500. You get it? So that's an example of the way how these are different. Eh? The trade one is given at the trading point. Then the cash one is given at the point when someone is making payments. Hope that is clear. Okay. Hello?
Hello, sir. We are together.
Question 14b is asking us to show the difference between IRR, internal rate of return, and the NPV. Now listen. NPV is basically the difference between cash inflow and the initial investment that is invested by the investor, right? That is NPV, net book value, is the difference between cash what? Inflow. In short, you're asking yourself, how much do you receive from this investment? That's cash inflow. You make an amount, you invest some money into a certain project. Then this project is going to give you some money, all right? So now, since it is going to give you some money, yeah, you need to get the difference, okay? You need to get the difference between how much you will receive from this investment and how much you inject into it. So the difference between cash inflow and the initial investment, right? Initial investment, how much you invested, that difference is what you call NPV. Now, the accounting or the internal rate of return, IRR, is the rate of return on an investment as compared to the cost of capital. Okay, this is the rate of return on an investment, right? The rate of return on an investment compared to cost of capital, right? So it is a question of how much of the return, the return do you receive from this investment as you try to compare the investment to what? To its costs, to the cost of the investment itself. How much of that do you receive? Is that clear? NPV, net present value, that's the full name, is the difference between cash inflow, basically how much you are receiving from the project, and the initial investment, how much you injected in the business. That's the difference. That's the NPV, net present value, while IRR, which is internal rate of return. Internal rate of return, it is the rate of return, on an investment as you are trying to compare it to the cost of capital of that investment. Is that clear now? We are good? We cross over to the partial fractions. Are we good there? People are quiet.
For me,
can you see
I
the
was
screen?
locked out. I didn't understand there since I was locked out.
Okay,
but
I'll repeat. I said the net present value, NPV, is a difference between how much you invest in the project and how much you receive from it. So the difference between cash inflows and the initial investments. That is what NPV is all about. But when you check the IRR. The IRR, internal rate of return, if you want to call it that way. It is the rate of return on an investment compared to the cost of capital. You got it? I even wrote some.
Yes, sir.
Now, let's go to see. I am hopeful that many of us had time to do the assignment of passing through partial fractions. The classes I've been having in partial fractions, quite a lot of them. You understand partial fractions this time around. So I will not really make the recording very lengthy to start again talking about partial fraction one more time. But I will just go straight to the solving of the question, bearing in mind that you've been following partial fractions from the sessions we've been having. So let's get to questions 14C. Express each of the following as partial fractions. Part 1. Now, look, when you look at this this question, x raised to the third degree, 2x raised to the first degree, x raised to second degree, right? Plus 3x plus 2, this quadratic. When you check this function, you will notice that the numerator has got the highest power as compared to the denominator. So before you could go ahead and dissolve this function or decompose the function, as a partial fraction, you got to divide, this quadratic into this numerator. Okay, so let's use long division and divide these fractions. The numerator being x to the power 3, right? We could arrange this plus 0x to the power 2. Since we don't have the x to the power 2, this one is just a placeholder, right? Because you could say 0 times x squared is just as good as 0. But we're trying to hold a place, and you'll see why we are holding this place very soon. So when you move, the powers are moving 3, 2, 1 in a descending order. The next power is power 1, so it will be negative 2x. If you had a constant, you could have then put a constant from here. So this is just the same thing as this, because here this is 0. It's just a 0. It's as good as there is nothing here. We haven't changed anything. So when we get here, you will divide x squared plus 3x plus 2 into this particular function. And when you have all these, then we can proceed. So you've heard, let's start dividing first. We reduce this fraction. Now listen to the way how we are dividing, and follow nicely to the way how we are dissolving, we're dividing. So we are saying you pick this first entry here, x squared into x cubed. You get it, right? Or rather x cubed divided by x squared. What do you get? What is x cubed divided by x squared? X cubed is same as x times the x, x times x times x 3 times I. That's x cubed, right?
Yeah.
And the x times the x, that's x squared. And if you were to divide this into that to cancel that and that to cancel, you remain with x, yeah? So that's why you're saying x cubed divided by x squared is just as good as x. Is that clear? So you have x, that's the answer. I know. You need to be reminded of long divisions. Maybe. You remember long division, those stuff you did, I don't know the grade, whether it was 1 or 2, I don't know. But there was that mathematics you were doing for long division like this. You remember where you're putting number here, maybe 124 divided by, let's say, 3. You remember such math where you're saying this 3 into 12. it goes 4 times, right?
Yes.
Then you multiply this 4 times 3 here to give us 12 down here. Then you minus, right? That's what you are doing. You are deducting and you're starting from the right hand side. 4 minus this 0 here, because this is as good as 0. 4 minus 0, it would be 4, right? I just want to remind you. And this will give us 0. So we have 4. Then again, we start this 3. Something like this. This 3 into 4, it goes once, right? Then you say 1 times 3, it gives you 3, right? Then you say 4 minus 3, it's 1. So now, since 3 can't enter into 1, this is your remainder. So 3 into 12, it goes how many times? 41 times the remainder, 1. Isn't it? You remember something
Yes.
like that from primary school. So this is almost the same thing that we are still repeating here. Yeah, this is basically the same stuff that we are trying to explain to you. So let's continue. So we are saying x this into that gives us x. Then start again multiplying x times x cubed. It will give us, follow nicely now, x times x squared, it will be x cubed. X times 3x squared, that would be what? That would be
3x
3x
squared.
squared. And the x times 2, that would be what? That would be 2. 2x, right? Is it?
Yes.
X times 2 is 2x. Like this. Then in the similar manner, you deduct, right? That's what we are doing. Negative 2x. Is this negative or is supposed to be positive? It's supposed to be positive, yeah. Positive 2x. No, this one is supposed to be negative. This is negative, which is on top. Negative 2x minus 2x, it will be negative 4x, right? Is it?
Yeah.
Like negative 2, that would be negative 4. Then you say 0 minus 3x squared, it will be negative 3x squared, yeah?
Yes.
0 minus 3x squared, you have negative 3x squared. Then in 3x squared minus 3x squared, we know that that is 0. Then again, when we get here, again, you start dividing. Remember? You have to divide again. You start afresh again. This into this. It goes how many times? Right? Negative 3x squared divided by x squared. We have negative 3, right? Isn't it? Because the x squared and x squared will cancel, colleagues. You will remain with negative 3, right? Then you start multiplying negative 3 times this, negative 3 times that, and negative 3 times these 2. So let's go and do that. So we will start to say negative 3 times 3x squared, it will be negative 3x squared, right? Negative 3 times 3x squared, that will be negative 9.
9x.
Negative 9x. And negative 3 times 2, that will be negative 6. Right.
Yes.
Isn't it? There is a 0 on top. Then we deduct again. You know the story. 0 minus 6, it will be positive 6, yeah?
Yes.
Negative 4x minus 9x. What do we get? Negative 4x minus 9x. Which means here there will be positive for it. So it will be negative 4x plus 9x. It will be 5, right? That will be 5x. Right.
Yeah.
You subtract the smaller number from the bigger one and retain the sign of the bigger. And then when you get here, it becomes very easy. Now you check if the remaining number can be divided into, we want to assess whether this is a remainder, okay? We are checking if this number can enter into this number without leaving a remainder, okay? So let's check, can x squared enter into 5x? Obvious, definitely it can't enter because this denominator will be higher. It will be like this, it will be x to the power 1, then x to the power 2. They can't divide. You get what I mean, eh? So for that reason, this will be your remainder. Okay? Are you following? Okay. Your answer is x minus 3, remainder 5x plus 6. So now, going forward from here, we know that when you write this shall equal to x minus 3 plus the remainder is 5x minus what? Is it 5x minus 6? This is plus 6. Divided by, you solve this fraction, the quadratic fraction, you know, and find to express it into its own factors using the notes you learned from, what's this? From quadratic functions. So you have x plus 1. Those are the two factors that you could find when you solve this fraction, and the x plus 2. We solve this denominator like that. If you solve this quadratic, whether you want to use the formula method, that one which says negative b plus or minus, you know that stuff, eh? B squared minus 4ac over 2a. This thing that the solving of the quadratic functions, basically, that's what is there. And you could reduce the function to that. Once it has been reduced to that, then it becomes very easy for you to do now. When you're solving the partial fractions, this is how it is going to be done. You're trying to express the numbers that will help you look at the way how it is getting to be. 5x plus 6 over this x plus 1. These are partial fractions. Plus 2 is equal to, one of them shall bear a, as we have been saying always. This will be x plus 1a, plus the other one will be b, right? Over x plus 2. Isn't it? This is the exact thing that you have been following when we have been looking at partial fractions. So now what we are trying to do from here is to look for the values of a and b. And we know that the values of a and b can be found by just multiplying on top here x plus 1, these factors in the denominator, and x plus 2 like that, over 1. When you start expanding like that, you know that we saw that this and this can cancel. This is what we have seen. So that we can just remain with 5x plus 6 equal to, when we are on a, we are multiplying this whole function, this whole denominator, this x plus 1, x plus 2 times a, okay? It will just give us something like this, a, x plus 1, close opening, x plus 2 on top, divided by x plus 1. And then x and plus 1 and x plus 1 will cancel. You've seen what I was saying. So that you can just remain with a times x plus 2. You close. You do the same when you get to b. B as well will be b times x plus 1 and the x plus 2 over x plus 2. Then x plus 2 and x plus 2 will cancel. Then you remain with x plus 1. Okay? I guess this should be straightforward if you followed the partial fractions as I guided. Then you have x plus 1, that is what will remain here. And so from here, we can basically just be there to solve for the values of A and B. A continuation from here shows that if we want the value of A, listen carefully, if we want the value of A, we can set the value of B equal to 0 by getting the factor that is on B, this x plus 1, and set it equal to 0. When you set it equal to 0, so for x, this 1 will cross the equal sign, it will become -1. And so in this entire function, wherever there is x, we're going to be substituting by putting -1. So you shall have 5 multiplied by -1 plus 6 is equal to A multiplied by -1 plus 2 plus B times where there is x, you put -1 plus 1. And we know that this part will give us 0, right? -1 plus 1 is just 0. 0 times B will be 0. Then -5 times -1 will be -5 plus 6 equal to A times -1 plus 2 is, what is -1 plus 2? -1 plus 2 should be 1, right? 1 times A is basically A. So -5 plus 6 gives us 1 equal to A. So that 1 is equal to A, or A is equal to 1. Is that clear? We have found the value of A. Simple. Did you get that? We have found the first value of A equal to 1. Let's now solve for the value of B. It's the same thing. If you want the value of B, then you have to set A equal to 0. How do you do it? Get the factor, this factor which is on A, this one, x plus 2, set it equal to 0. And so for x, it will be x equal to -2. And where there is x in the function, replace by putting -2. Plus 6 is equal to A multiplied by -2 plus 2 plus B times -2 plus 1, like that. So we can easily solve the function, yeah? 5 times -2 should give us -10 plus 6. That should be equal to, this will give us 0, because -2 plus 2, -2 plus 2 is 0, times A is basically 0. And then you have B times -2 plus 1 is basically -1. -1 times B, this will give us -B. So that you can have -10 plus 6, giving us what? What is -10 plus 6?
-4.
-4 equals to -B. So we want the value of B, just divide throughout by -1 so that B can equal 4. Is that clear? So the value of B is equal to 4. Now that you have found the value of B equal to 4, then it becomes very easy. This is how your function will be. This is the function. This is how A will be, right? Part A will be. How is it going to be? Part 1 will be. This is part 1. It will just be x, to the power 3 times 2x over this function. This is as good as just x plus 1. I told you how to dissolve this. This is what I've said. It's equal to your A. What is our A? Our quotient was x minus 3, then plus our A was 1, right? 1 over x plus 1 plus B was 4 over x plus 2. Nothing much, nothing less. This is the function. This can be put together like this. So this is your solution. You got it? Yeah, so this is how you find this one. But part 2 is quite easy as well. Part 2 is what we want to do now. This one is for the repeated fractions that I was talking about. These are repeated fractions. It means that this fraction is repeating twice. X plus 1, this factor is repeating twice. So you could rewrite it as x squared divided by x plus 1 and x plus 1. Okay? So that it can be equal to what? You have to expand this. Expand this. Let's expand this denominator. X times the x plus 1 times the x plus 1. It will be x squared, right? Plus x plus another x plus 1. So that it can be x squared plus 2x plus 1. That is the denominator. Now, when you check this denominator that you have, it is an irreducible quadratic. It can't be reduced further. So you have to divide. This function here, we expanded it. It's as good as x squared plus 2x plus 1. It's the same thing. Now, when you check this again, you go back to what we were doing again. You need to divide. Okay? So you will need to divide x squared plus 0x plus 0. I said these zeros are just placeholders. Divide x squared plus 2x plus 1 into that. Let's reduce this function as well. Again, we start x into x squared. What is x into x squared? It's 1, right? Hello? X squared into x squared is just 1, right? That was 1. 1 times that, it will be x squared plus 2x plus 1. Like that. Then let's deduct. When we deduct, we'll have -1. Hello?
So you said x squared divided by x, it's 1.
No, x squared divided by x squared. Like, look, this is x squared and this is x squared.
Oh, all right. Okay. It's clear.
When you deduct, you have -2x here, -1. And this will give you 0. X squared minus x squared is 0. Now, when you check, this is the highest power. It can't enter into this, right? This will be your remainder. So that your function can be equal to 1 plus, the remainder will be negative, 2x minus 1 divided by this factor that we had broken down to x plus 1 and the x plus 1. So this is what we are working out again. We're working out x plus 1 and x plus 1 throughout. Let's quickly work out this. If you get this, then part D is very straightforward. Because we just get the answers of gotten here and integrate them. So very easy. So how is it done? You have -2x minus 1 divided by x plus 1 and x plus 1, right? So this will be equal to a over x plus 1 plus b over x plus 1 squared. This will be squared. And when we multiply throughout by x plus 1 squared as the highest power, you will have that, this and that cancel, like the way how we're doing it. This and this will cancel, so that you can just remain with -2x minus 1 this side equal to. Then when you say a times x plus 1 squared divided by x plus 1, x plus 1 squared will be divided by x plus 1. So one of them will cancel and you remain with 1. None of them. So you will have a times x plus 1. Plus on b, both of them will cancel. It will just be plus b like that. So we can easily work out that. So to work out this, you can say now, if x is equal to, get any random values of x from 0, 1, 2, 3, and negative 1, 2, negative 3, like that. So if we say, if x is equal to negative 1, let's say if x is equal to negative 1, then we'll substitute by putting negative 1 everywhere there is x. It will be negative 2 times negative 1 minus 1, right? Is equal to a times the negative 1 plus 1 plus b, right? So that when you solve, negative 2 times negative 1 is positive 2 minus 1 equals to, this will give us 0 because negative 1 plus 1 is 0 times a is 0. So that b can be equal to 2 minus 1, which is 1. So b is equal to 1. Is that clear? We found the value of b. B is equal to 1, right? What if x is equal to 0 now? What if x is equal to 0? If x is equal to 0, then we'll say negative 2 times 0 minus 1 is equal to a times 0 plus 1, right? Plus b, right? We want to solve for a. So what are we going to have? What is it that we'll have? Negative 2 times 0 is 0, so we'll have negative 1 equal to a, because 0 plus 1 is a plus c, b, right? And b we already have is 1, right? Yes. We said b is 1. Is it b or a, which is 1? It's b. So have negative 1. Negative 1 is equal to a minus c, 1. B is negative 1. Oh, it's 1. It's just 1 positive, not even negative. So when you collect like terms together, this will be negative 1 equal to a, so that a can be equal to negative 2, yeah?
Yes.
Our a is negative 2. Then very easy from here, we can easily summarize now. Therefore, say therefore, our fraction was negative 2, x minus 1 over x plus 1 squared equal to, our a is negative 2 over x plus 1 over, because b is 1, it's 1 squared, like this. This is the answer for it, plus 1. And then when you get to d is easy, just the integrals of these. So the answers that we have found, then we integrate them. So for example, let's start with the first one. We had found the answer. Our answer was 1. What was our answer that we should integrate? That's part D1 now. It was x minus 3 plus 1 over x plus 1 plus 4 over what? X plus 2. This is what we found. So when you integrate this is one thing. You use the integral symbol everywhere. It will be, the power will increase. This will be x squared divided by 2 plus 3x. That's how it will be, this part. Plus the natural log of x plus 1, the denominator, plus 4, the natural log, ln. This is ln x plus 2, plus c, the constant. This is the answer. Very easy. That's the answer for part 1. I'll talk about the integration of natural logs at some later point, but as for now, let's pick this as the truth. This is how it is. Then part, what is this? Part 3, part 2. Just to get the answer, it was, what was it? It was 1 plus the negative 2 over x plus 1 plus 1 over x plus 1 squared, right? So if you are to integrate this, then you could easily integrate it, right? You could easily integrate this as the integral of, let's integrate, the integral of 1 is x, minus 2, the natural log of x plus 1, and minus plus 1 plus 1 plus 1, the natural log of x plus 1 and square plus c. C is always there when you're integrating, and that is a constant for you. All right. So that is the application of those those partial fractions that I'd said. That was question 14 of the quiz.